inelastic collision. The word collision here we go, is defined as two objects hitting each other. Sometimes they're reversed, by the way. They're stuck together, explosion will happen, separates them two. But two objects strike each other in which the net external force is zero or very, very small. We call that a collision. Now, usually most collisions have conservation of kinetic energy, which means the kinetic energy before equals the kinetic energy after. But any collision in which the kinetic energy is not conserved, it does not equal to each other, is known as inelastic collision.
Just out of curiosity,
Yep.
Is there a word for if the force is large? Like, what would you call it?
The force is large?
Yeah, because, I mean,
Yeah.
I'm just curious.
Yeah, just a
'Cause
term?
a collision is a
Yep.
small force.
I don't know what large force would be called if there's a name for it.
I'm just curious.
Yep, I'm not aware. Like humongous force, no. So what is then inelastic collision? Basically, if two objects hit each other and stick together, that's definitely inelastic collision. Or they were stuck together, explosion happened like a spaceship. That's how the spaceship, by the way, worked on that logic. They used to put the astronaut in the capsule when they come home. First, they live together in the whole thing. Then at the end, when they're ready to come home, they move to the back end of the spaceship. It's a little capsule. They close the door. A little explosion will happen. They want that explosion because that explosion will separate the two pieces, will ship the payload forward, and they bring the other piece back to Earth. So that's called inelastic collision. So inelastic collision the final linear momentum. We still have conservation of linear momentum, but the kinetic energy does not equal, the final one does not equal to the initial one. So we can use the kinetic energy for inelastic. And when they stick together, we call that really completely inelastic. And that's what we're going to use. So when they definitely stick together, that's what we're talking about, completely inelastic collision. I was watching the Women's Soccer World Cup yesterday, and you saw the ladies hitting the ball with their head. The ball doesn't stick to their head, it bounces away. That's not inelastic, that's elastic collision. You watch a train coming in, or you're trying to tow a trailer behind you. You move your truck backward till it hooks on that trailer, then they start to move together. That's elastic collision. Completely elastic. They're stuck together and they move together. Or you see the train coming in, hooks to another one, continue moving forward. Those are elastic collision. You see it in sports too, in hockey, especially in football. When a person runs and tackles somebody, they grab them, hold them down, and they go together. That's elastic collision. I mean, inelastic, I'm sorry. They stick together. Elastic when they bounce. Like in hockey, sometimes they don't stick together. They do bump each other. That's, you look at it like elastic because they don't stick together. But if they grab them and hold them, and they move together like in football, that's inelastic. So let's take an example with inelastic or completely inelastic. Let's say we have, this is the before versus the after. We have a train. One of those is moving forward, has a mass of 10,000 kilogram, and is moving to the right of velocity of, 5 meters per second. Hits another cart, has a mass of 15,000 kilogram, but is not moving. After the impact, we're talking about trains here, what will happen? They usually stick together. So after the impact, they're going to look like this. They get coupled together, and now the system here is going to move, I'm assuming, forward of velocity v. The question, how fast they're going to be moving? What's the speed there now? That's completely inelastic collision. That means the initial linear momentum should equal the final linear momentum. What's the initial linear momentum? Mass times velocity. Well, for the first one, this is number 1, this is number 2, this is 1, and this is 2. The mass of the first one times the velocity of the first one plus the mass of the second one times the velocity of the second one. Here they stick together. The mass, they become what? The mass of the first plus the mass of the second. They become one object, and that's how heavy the object. Times the velocity to the right. What's the mass of the first one? 10,000. What's the velocity? 5. What's the mass of the second one? 15,000. What's the velocity of the second one? 0 equals the combined mass, which is what? 10,000 plus 15,000 times V. 50,000 equals, what's that, 25,000 times V? What's V equal to? 2 meters per second. Notice it's positive value. That means the direction I assumed is going to move, it is correct. I'll take another one. That happens to me all the time. I have a standard for a car, and a lot of times I'm not paying attention. I notice the car is rolling backward. So I'm on a hill there, stop at the light there. But here's the problem. The mass of my car is, let's say, 1,500 kilogram. And I wasn't, this car number 1, I wasn't paying attention. My car was rolling backward because my foot was not on the clutch all the way there, or on the brake. I had it on the clutch, but I wasn't pushing the brake that far. It's moving backward, is rolling backward of velocity of what?
What's the mass?
1,500. The velocity is backward, let's say it's 5 meters per second.
Should we make it negative since it's...
Well, I'm just drawing the direction. When I get to the numbers, I will, yeah. Now, there's a small car here, a smart car, coming behind me. You know, they don't weigh that much, maybe 500 kilogram. And is moving in this direction. And let's have a speed of 1.5 meters per second to the right. He's moving forward, rolling forward, I'm moving backward, we hit each other, and somehow the bumpers got stuck together. So this is the before. Now what happens after? His car is stuck under my car. See, it's stuck together. So the two cars are stuck together, and I have no idea which way they're moving. So I'm going to assume we're going to be going What do you think? Up or down? Okay, let me change this to 2 instead of 1.5. 2 meters per second. Or ten meters per second, not 2. Moving. Which way do you think, up or down now? Up? Okay, we're going to make the assumption you're moving upward. Actually, still going to be down, but that's okay. I don't want you to know I want it to be wrong intentionally. So let me define this direction as positive, and let me define this direction as negative. So this is the after. And we're not sure which way it's going to move. So I put it going up. I took a wild guess. So the initial momentum before equals the final momentum. The initial equals the final. The momentum before equals the momentum after. What was my momentum before? I got the mass of that smart car. Let's label this car as car 2 here. The smart one. This is 1. This is 2. This is 1. So it's car 1, mass 1 times V1 plus mass of the second one times V2. After the impact, the two masses, they're stuck together, the two cars, we add them together, times the velocity V. And let's put the numbers and use positive and negative based on the direction. For car 1, what was the mass? 1,500. What was the velocity? What is it? Yep, -5. For car 2, what was the mass? 500. What was the velocity?
10.
+10. When you put the two cars together, what do you have for a mass? 2,000 times the velocity. Five times 5 is 25. Is that -75? 100, I think. -2,500. 2,000 V. To get V, we divide by 2,000. -1.25 meters per second. Notice as my velocity is negative, which means what? My direction, I assume, is going upward, is wrong, is going to be coming down. So the net velocity rate is still going to be down over the value of 1.25 meters per second.
So the exam, do you want it in the positive form?
What they're going to probably tell you
Or-
on the software, like going up, going down,
Oh, okay.
you know. So if they say going down, then you go 1.25, you know it's going down, you know.
But what if it doesn't say?
Then they're probably going to ask you for the speed, which means a vector. You know. But they have to specify or ask for the speed. If I made this 15, guess what will happen? They'll stop. They hit, stick together, and stop. If I'm at that 15, because this side will be a 0 now, 2,000, 0 divided by 2,000, 0. So I can play with the numbers, make it go up, down. If I made, so 15 will make them stop. Under 15, they roll down. More than 15, the little guy will push this one upward. Yeah. The reason I know that's 15, because if you look at the mass, this is 3 times that number. See that, 1,500 to 5? This velocity has to be 3 times that number to cancel it. So 3 times 5 is the 15. Anything below that, this is too much momentum going through. It's going to come down. Anything over the 10, this will have more momentum going upward than this one will push it forward. Now, just to show you that the kinetic energy is not really conserved, let's look at the kinetic energy. What was the kinetic energy before and the kinetic energy after? They should not equal to each other. I'm saying they don't equal to each other, but let's prove it. What was the kinetic energy for this one? Kinetic energy is 1/2 the mass. The mass of the first car is 1,500 times the velocity squared. Kinetic energy is 1/2 mv squared. And what was the kinetic energy after? It's 1/2. The mass is the combination of the two masses, that's 2,000, times the velocity squared. And if I do my math, this side that are not equal to that side. $18,750. $25,000 here. $1,562.5. And when you add the numbers, no, it's not even close. Who the hell is sending me a text message? Forgot to put on silent. Notice they don't equal to each other. Love Verizon. You use 75% of your data plan. You should buy some more, but my data plan expires on the 23rd. What is today?
23rd.
Why would I buy more if I still have 25%? The power of numbers, you know? Okay, let's do a goal line stand. On a touchdown attempt, we have two people going to be blocking each other. So we got, there's two people. This running back, that's the running back, got the ball with him, wants to score a touchdown. His mass is 95 kilogram. And he's running velocity or speed of 3.75 meters per second. Here we got a big guy try to block him, linebacker. The mass of the linebacker here is 111 kilogram, and it's moving with the velocity. So this running back is going this way, this one is running that way. The velocity of this one is what? 4.10 meters per second. And they meet, well, the blocker, the linebacker meets the running back head on and holds him. If the two players stick together, here we go. If the two players stick together, So if that's the case, what is their velocity immediately after the collision? What is their velocity immediately after the collision? So here we go. This is the before and the after. The before, this is the running back carrying the ball. This is the tackler running at him. After, they're holding each other, moving together. So let's look at the linear momentum before. Now, do we know which way they're going to move? The two players. So which way you want to make them go? We make them go to the left, Alex? Alex want to make them go to the left. And I kind of agree with Alex. Why? This one has more momentum coming to him. It's heavier, moving faster. This has less momentum, so he's right. It's going to go to the... But if you don't know, it doesn't really matter. Don't even think about it. Just draw a direction. If the value comes out negative, it's your direction is wrong. It's backward. So the before, I'm going to use to the right is positive, to the left is negative. So now look at the linear momentum before. The running back has a mass of what? 95 kilogram. He is running to the right of a speed of 3.75. The linebacker is going to tackle him, has a mass of 111, but a velocity of negative 4.10. Now they stick together, so what's the combined mass? Is it 206? 111 plus 95? I think it's 206. And the velocity is negative v. I'm saying it's going to go to the left, so I'm using negative to indicate to the left. Let's do the math and see what that number, 95 times 3.75, I can do the whole thing in one shot, minus 111 times 4.10. The left side is minus 98.85. What is V equal to? A negative divided by a negative is positive 0.48 meters per second. That says I was right with my assumption. Notice 0.48, it says, yep, your assumption, the direction you go into the left is correct. And how fast? They're going to move together with initial speed of 0.48 meters per second. If I made it go to the right instead of the left, this would be a positive V, which will make the number negative. That tells you, oh, the direction should be backward. This is one of my favorite experiments we do sometimes in the lab. We don't use guns in the lab, but imagine this. You have a block of wood attached to a string, like pendulum. Somebody fire a bullet at it. It's a big block of wood. Here comes the bullet. The bullet is moving. So the mass of the bullet Bullet is really small. Let's say what, 10 grams. Has a velocity, is moving really fast of, I don't know, 600 miles per hour. Strike the block of wood. This bullet goes inside the block of wood. The wood here, mass of the wood, let's say it's 2 kilogram, and is dangling. Has initial speed before the bullet hits it of what? 0. Well, what happens as the bullet goes into the wood? That wood, it goes inside it. It didn't come out of the other end because why? The wood swung like this. It moved up. And the question, how high did it go? What's the height of that? And the bullet's still inside it. So traveling through that piece of wood, the piece of wood attached to a string, the string moves forward with the block and the piece of wood stuck inside it. This is actually 2 problems in one. Here's the first part. The first part is the bullet coming in. The block of wood is sitting here. The mass of this is 2 kilogram. The velocity of this is 0. The mass of this 10 gram, which is 0.01 kilogram. The velocity of this 600 miles per hour divided by 2.24, which is 267, that's equal 267.9 meters per second. It goes inside that. And now my question, what's that velocity, initial velocity right there, or the final velocity? So what's that velocity right there once the bullet goes inside the wood? Can you tell me what that velocity is? It went inside, now it goes in it, now they're going to swing. So what was that velocity there? What kind of collision we have here? Inelastic, completely inelastic. So if I take the mass of the bullet times the velocity of the bullet plus the mass of the wood times the velocity of the wood, it should equal to what? The mass of the bullet plus the mass of the wood, because they're stuck together now, times the velocity, which is v. What is the mass of the bullet? 0.01. What's the velocity? 267.9. Plus the mass of the wood, 2 kilogram, times the velocity, which is what? 0, equal the combined mass, 2.01 times v. 2.679 plus 0 is 2.679. Can I get what v equal to? It is 1.33 if you carry all the digits. Meters per second. Yes?
Why are you using 267.9 for the velocity instead of 600?
Because that's in miles per hour.
Okay.
So that's equivalent to 267.9 meters per second. That doesn't really help me. The question is, how high did the block and the bullet rise?
Can we use one of like the original equations?
Okay.
I don't know, I'm throwing out an idea.
It says use the original one. The original one only if you go in one dimension unless you have projectile.
1/2 of mv squared,
What is it?
or maybe 1/2 mv squared.
If we assume there's no friction on the top, like where this one attached, it wasn't rubbing friction there, we can use conservation of energy. If we neglect the wind there, the potential and the kinetic energy here equals potential and the kinetic energy right there. So as the second part of it is right there. Has a mass now of 2.01 kilogram. It's moving with the velocity of 1.33, and it's going to go like this. It's going to go right here. The mass, still 2.01, the bullet's stuck inside that. Hey, what's the velocity when you reach that point? Isn't that 0 for maximum height? Stop moving. So this is h. If I use this as reference, now I have conservation of mechanical energy. If I take the potential energy plus the kinetic energy should equal the final potential energy plus the final kinetic energy. Remember, potential energy, it's mass times gravity times height. Kinetic energy, it's 1/2 mv squared. So here we go. The potential, it's the mass. Gravity, which is 9.8. What was the initial height? 0. The kinetic energy, 1/2 the mass times the velocity squared equals what is the potential energy when you reach the peak there? The mass times gravity, which is what? 9.8 times the height, which is what? H. Plus the kinetic energy, 1/2 the mass times the velocity squared. What's the velocity? 0 when you reach the peak. So I know these two numbers because you're multiplying by 0, they'll go to 0. So I end up with 0.5 times 2.01 times 1.33 squared, 1.78 equals 19.7 times h. Can we solve for h here? 1.78 divided by 19.6, 0.09 meters, which is 9 centimeter. So the block of wood risen now 9 centimeter with the bullet inside it. And I'm not sure how heavy the bullet, to be honest. I made it 10 grams. Couldn't tell you what real bullets are. If we known that, and we probably could get a bigger answer or better answer. And I also made the block of wood heavy here as the combined mass. One more thing on this, then we're done with this section, and that is every example I did with collision here, inelastic collision, was one dimension. Notice one dimension, moving to the right, moving up and down this road, that's one dimension. They're tackling each other, one dimension, in this direction. One dimension. So what happens if two dimensions? You just start dealing with two dimensions. Like what? You get to this road here. This big intersection. So this is car number 1. Has a mass of 950 kilogram, and it's coming toward this intersection, is going this way, velocity of 16 meters per second. Now we got a minivan here. Here we go. It has car number 2, or the minivan is number 2. The mass of the minivan, a little bit bigger, heavier, has some kids in it. We don't want to kill anyone. Of 130 kilogram, 1,300 kilogram, not 130. It has a velocity, the minivan was going 21 meters per second, going to a soccer game, speeding up a little bit there. They get to the intersection, neither one of them slows down. Well, guess what's going to happen? They hit each other, but let's assume for the sake of this, they're stuck together. So now, here we go, there's the car, all dented. There's the minivan inside the car, all, and they're going to travel in that direction, basically. That's what's going to happen. The two of them stuck together. Let's find the velocity here, how fast they're going to be moving, and also the direction, theta. What's that angle? What we need to do, look at in the x direction and the y direction. Okay. X direction. X direction, that's to the right. That's the x direction, and this is the y direction. In the x direction, the initial linear momentum should equal the final linear momentum. Let's look at the initial linear momentum in the x direction. Car number 1, what was the mass of that car? 950. What was the velocity of the car? 16. Car number 2, what was the mass? 1,300. What was the velocity of car number 2 in the x direction? 0. It wasn't going in the x direction. The net result. Now the two cars stick together, they become one mass. And how heavy that car now? Is it 2,000, or I'll go 950 plus 1300. I'll do it like this. I'll use a calculator for that. And what was the velocity in the x direction here? What was the velocity in the x direction of these?
Together.
Yep.
Zero. Cosine.
Can't be 0. It's going that way. Yep.
Cosine theta.
V cosine theta. Whatever this value times the cosine to get the value in that direction. So we know this piece goes to 0. So we have 950 times the 16, 15,200 equals 950 plus 1300, 2250 times V cosine theta. So if I divide by 2250, I have 6.76 equals V times cosine theta. Notice there are two unknowns in this equation. Now let's look at the y direction. So this was the x direction, right here. Let's look at the y direction. In the y direction, let's look at the car here, the 950. What was the velocity in the y direction of this car? How fast was this car going up and down? 0. Plus the minivan, which is the mass 1300 times the velocity in that direction, which is what? 21, equals the combined mass. And what was the velocity in the y direction? V sine of theta. $27,300 equals 2250 V sine theta. I'm going to divide both sides by 2250. V sine theta equals what? 12.1. And that's my second equation. So now I have two equations by two unknowns, just a matter of solving them. This is one, this is the other one. So let me write the two equations down, try to solve them. Physics is over. Now it's the math. V sine theta equals 12.1. The other one, V cosine theta, equals 6.76. And now solve them. I can solve these any way I want. I can use substitution, or I can just take the two equations and divide them. If I divide this by that, the v's will cancel each other out. What's sine divided by cosine? Tangent. What's 12.1 divided by 6.76? 1.79. To get theta, it's always the inverse tangent. second tangent, 1.79, 60.8 degrees. And you can grab either equation now. Sine 60.8. I took that equation to solve for V. So take the sine of 60.8. 12.1 equals V times 0.87. So what is V equal to? 12.1 divided by 0.87. 13.9 meters per second. 13.9 meters per second. How many miles per hour? 2.25 or 4. Going 31 miles per hour, approximately. So the two cars will hit each other, stick together. Instead of staying on the road, they're going to move over the grass in that direction. Velocity of 13.9. This angle here will be 60.8 degrees. It should be toward the Y because this is heavier car moving faster. So it's going to push it. If this was the heavier moving faster, this line will be broken like closer to the x-axis instead of the y-axis. But you have to break it down to x and y component.